Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at data and sampling. So we'll start by looking at types of data. There are two main types, categorical and numerical. Just note in science, you might call this qualitative data and you might call numerical data quantitative. So how do we distinguish between these two main types of data? Well, imagine that you were collecting data and you were asking a question. Would the respondents give you a word or category, or would they give you numbers? So there are two types of categorical and two types of numerical data. So you need to know four types of data in all. So let's start with nominal, which is a type of categorical. So nominal data is where someone just responds with a category. An example would be eye color. You ask someone their eye color, they're going to give you blue, green, brown, whatever. It's like they're giving you a category. It's like you're putting the eye color into groups. You're grouping people there. They're definitely not going to give you a number. The other type of categorical data is ordinal. So people here are still giving you a category, still giving you words as their answer, but there is an order to them. A quintessential example of ordinal data would be surveys you've completed where they give you a statement and you have to agree, strongly, disagree, strongly disagree, or whatever. Of course, I could have more options than this, but there's a clear order to these. So for example, I might say, how much do you agree with the statement, I love maths? Do you strongly agree, disagree, or strongly disagree? So there's an order here because these people love maths more than these people, and these people love maths more than these people, and so on. As for numerical data, there are also two types, discrete and continuous data. Discrete data has to be in numbers, but it's where the numbers can only take certain types of values. So an example would be shoe size. If I ask someone their shoe size, they're going to give me a number, so it's numerical. But your shoe size is either a whole number or a half number. Your shoe size can be 12, 12.5. It can't be 12.129, for example. It can only be a certain type of number. That's why it's discrete. On the other hand, continuous data can take any number within a range. So for example, if I were to measure the time taken for you to run 100 meters, it might take you 12 seconds or 12.0129 seconds or 12.3456928 seconds. It doesn't have to be a whole number or a half number. It can be like any number within a range. That's what makes it continuous. Now, a rough way that you can distinguish between discrete and continuous. Discrete is usually data you count and continuous data that you measure. So as another example, let's say that I ask how many friends you have on Facebook, if kids still use that. Well, that is something you count. You're counting the number of friends. It would be discrete. Let's say, on the other hand, I ask you to tell me the length of your index finger. Well, that would be something you'd measure. You'd get out a ruler and measure it, and the length doesn't have to be a whole number or a half number. It can really be any value within a range. Now, sometimes it can be a bit tricky distinguishing these two, even with the hints I gave you. So let's say we're looking at height. Now, height's definitely continuous. It's something you measure. You might be 178 centimeters tall or 178.1239 centimeters tall. Your height doesn't have to be a whole number. If, however, I said we're going to measure your height to the nearest centimeter, those values would be discrete because they'd have to be whole numbers. So sometimes it can get a bit tricky, but as a general rule of thumb, continuous is numerical data that's measured, discrete is numerical data that's counted. All right, let's now look at sampling. So let's first go through a few definitions. So the population that we mean in statistics is everyone of interest. So let's say I wanted to know about how many hours of homework Year 9 Lynham High students complete. So because I'm interested in Year 9 students at Lynham, everyone in Year 9 at Lynham comprises the population. If I ask everyone in Year 9 at Lynham, I have conducted a census. I've asked everyone of interest. Now, it might be a bit impractical because it would take a long time to ask everybody in Year 9. So instead of asking everyone, I might just ask some of the people in Year 9. When you ask just some of them, which is a sample of the population, you've conducted a survey. Now, when you're conducting surveys, it's really important that you avoid bias. Bias is where your sample isn't representative of the population. So, for example, let's say I wanted to know about how much homework would be completed by Year 9 students at Lyneham. If I just asked kids in the LEAP class, that wouldn't be a biased sample because they probably complete more homework than average. The numbers I get from that data are not likely to be typical of all students in Year 9 at Lyneham. There are heaps of ways we can get a bias sample. Let's say I'm interested in the height of students at Lyneham. If I only ask boys, that won't be representative because they tend to be taller. If I were to look at just English results of students at Lyneham High, if I only ask girls, that is a sample, because I haven't asked everyone in the population, but it wouldn't be representative because girls tend to perform better in English. So we don't want a situation where our sample gives us higher or lower results, because then what's really the point of conducting the survey? Another way that we can introduce bias is called interviewer bias. This is where the interviewer does something or there's something about them that changes or skews the results. So one example of interviewer bias is when you're asked leading questions. So let's say I want to know about how much homework Year 9 students at Lyneham complete. If I start off by saying I like students a lot better if they complete more homework, how much homework do you complete? That's interviewer bias. It's a leading question because I'm sort of enticing the respondent to say they do more homework. And you can think of interviewer bias in many different ways, but it's basically where the interviewer changes the results by their conduct. All right, let's now look at some types of random sampling. So we've just seen that when we conduct a survey, when we don't ask everyone in the population, sometimes there is bias. If our sample is not representative of the whole population, we have bias. So the best way to eliminate bias if you're conducting a survey is to sample randomly. The people that actually respond, the people you ask, are chosen randomly. So there are 3 different ways that this can be done that you need to know about. So first is simple random sampling, where everyone in the population has the same chance of being picked. So for example, if I am interested in Year 9 and how much homework they do, I could give every student in Year 9 a number and use a random number generator, and if your number comes up, I ask you, otherwise I don't. So in this way, it's completely left to chance which students I ask. Systematic random sampling is where you ask every nth person. So for example, I might take the roll of all Year 9 students and ask every 5th person. Stratified random sampling is where you divide population into groups and you randomly pick one. So an example could be that you guys are divided into houses, into 4 different houses, and I randomly pick one of the houses and just ask the Year 9s in that house. That's a way I could do it. Now, these 3 methods don't automatically eliminate bias. It's still possible you get a biased sample, but it's a lot less likely. Now, you have to be careful, particularly with this one. As I said before, if I divide the population, Year 9 students, into boys and girls, and randomly pick either boys or girls, I could still get biased results, depending on the question. So again, we have to make sure that our sample is representative of the population. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.